Welcome everybody to this session where we are going to see, evaluate, and choose the right model in Amazon Bedrock. So my name is Juan Sanz. I'm Solutions Architect in AWS in Zurich. And today I will be presenting this session with my colleague Marco, who is a machine learning engineer. So Marco and I, we work together with customers who want to implement generative AI applications. Those generative AI applications, as you can already see, basically they are in the beginning difficult to build because, of course, this industry is changing so fast, and generative AI is already changing and transforming certain industries. So in Amazon, we empower developers and companies to use generative AI and the best LLMs or leading LLMs in the market to basically build generative AI applications and transform your industries. But choosing the right model is not a trivial task. It can be complicated. So today, what we are going to see is basically what are the important elements that you need to be or that you need to consider in order to choose the right LLM for your task. So probably you have seen already this slide. In AWS, we like to categorize our generative AI stack in 3 layers. At the bottom layer, you have the infrastructure layer, which is actually for our customers who want to build, train, and deploy the model on their own. So we offer everything that you need from the infrastructure point of view, like chips, GPUs, as well as Amazon SageMaker, which is our service that we put at the disposal of machine learning practitioners so that they can build, train, and deploy machine learning models. In the second layer, we have Amazon Bedrock, which is the service that we are going to see today. Amazon Bedrock is a completely managed service by AWS, and it provides basically leading LLMs at your disposal, and they can be reached through an API. As well, we offer other features and services on top of Bedrock that help you to build applications in a secure way, like guardrails, as well as other features like creation of agents, knowledge bases, and so on and so forth. For those customers who just want to consume generative AI without having to write any piece of code, we have the top layer, which is the application layer, where we have services like Amazon Q and Amazon Q for developer. So when we decided to release Amazon Bedrock, we talked to a lot of customers to understand exactly what was your specific need or your needs in general, right? And you told us that you wanted to have a way to experiment quickly, to be able to pivot, build applications fast in an agile way, and you didn't want to be constrained to one LLM, as well as the speed of innovation in generative AI world is very fast, as you know. So LLMs and new technologies are basically being released in regular basis. So you wanted to have the possibility to choose between different models, but as well adopt the greatest and the latest technology. This is why in Amazon Bedrock, now you can select models from all those different providers. But in case that you want to build your own model, you want to customize it as well, you have now the option to import customization models. So now the question seems to be obvious, right? With all those LLMs, plus all the LLMs that you can import, your customized LLMs, so which one to choose? I mean, somebody could argue and say, why don't we go to one of those public leaderboards, like from Helm, or OpenLLM leaderboard from Hugging Face, and just choose the highest rating LLMs? Well, in fact, reality is that this is not what is recommended. And there are different elements or factors to be considered why this is not the best choice. First one is context-specific performance. While those, of course, leaderboards provide amazing insights in how those LLMs basically perform certain tasks, for your specific task, those LLMs might not be the best choice. And I put you just one example. Those LLMs can basically perform very well in doing content summarization, but you are looking for an LLM that is going to do a specific math calculation. So it's always good to start, as we do in Amazon, in AWS, walking backwards from our customers. So in these cases, starting taking the use case first into consideration. Whatever is the use case that you want to implement, it may be a Q&A chat, it may be a summarization application that is going to take long documents and provide you a summary, or you might want to extract key information entities from documents that are scanned, for instance. This could be 3 use cases. Of course, there are many more. So today, we want to invite you to be part of one of our projects. This is, of course, a project that is not real, but Marco and I have to face this every day with customers. So Octane University is a fictional university, but it's leading in computer science research. And we are going to help Octane University to provide an application for the PhD students who they need to read quite a lot of scientific papers, articles, and they have to consume that in a very fast way, because basically in computer science, everything is evolving very fast. So we are going to help them to build a generative AI application that is going to summarize those scientific documents. But we need to take into consideration one important thing. The summarization needs to be accurate. So the model cannot create invented information. So before we jump into what could be the best models for doing the summarization, let's try to understand first some of the key characteristics of text models. So let's start by the intrinsic characteristics, which actually relate to the technical aspects of the model, which basically fundamentally will shape the capabilities and behavior of the model. And then we have the user-facing characteristics, which basically provide a more practical considerations for, or taking into consideration the end user and application point of view. Jumping into the intrinsic characteristics, we first have the training. So training is the process of exposing the model to a huge, vast amount of data. This is the first step. So the model is going to build its understanding of natural language. Of course, later on, the model, once has been pre-trained with a huge amount of data, needs to be tuned to be able to, for instance, comprehend that we are asking for instructions, as well that they are capable as well of having kind of human way conversations. So after the pre-training, there are some tuning phases. Then we have the size. So the size refers basically to the number of parameters that the model contains. And it reflects as well the model's capacity to learn and represent complex patterns and relationships within the training data. The size itself, by itself, is not representative only of the performance of the models. So there are others as well, factors that need to be considered. And then we have the architecture, which actually is the way that the model is organized, including its neurons and layers. So the architecture determines how the model is going to process input data, is going to learn from patterns, and is going to make predictions. So we have different architectures in the market, like encoder, decoder, only decoder, or now a mixture of expertise. Then we have user-facing characteristics. These are definitely, let's say, more impacting the user experience. And of course, use cases that the model supports. So in our case, we want to build a generative AI application that is going to summarize long scientific documents. So we need to make sure that our LLM, of course, supports this use case. The language. Most of models already support unofficially many languages, but if we want to have a model that is very accurate summarizing specific scientific documents, we need to make sure that it's going to support the languages that we want, whether it's English, German, etc. And if we have a use case which requires as well that the model is going to provide, I don't know, certain capabilities on programming language, we need to as well ensure that programming languages like Python, JavaScript are supported by the model. Then we have the context size. This is also quite important, right? So whatever the technology or mechanism that you use to do summarization, if we are doing, in this case, taking the document, uploading it, putting it in the context window, and asking for a summarization, we need to make sure that the model context window is sufficient to upload documents with might be 500, 600, 700 pages. And then the customization options. There are some use cases where we have proprietary data that only, of course, our company knows about. The model has no idea, so we need to customize those models, either using fine-tuning or using other mechanisms. So if that's one of our use cases, we also have to make sure that our models can be customized. And last but not least, the performance. If we are building a question and answer chatbot that is going to be used by millions of customers worldwide, and they are going to use it, I don't know, to ask questions about our products, we want to make sure that the customers are not waiting minutes to get a response, right? So once we have seen already all those characteristics, there is only one more element that needs to be considered before we start evaluation and the selection of the right model for us. And this is basically how we can measure, okay, these models that we have pre-selected already and compare them between them. For that, we need metrics. Metrics are essential for measure the performance of the LLMs in a quantitative and a comparable way. So in our case, it's crucial, as we mentioned before, that the generative AI application that is going to summarize scientific documents, it does it in a very accurate way. So we have to choose the metrics that are important for our use case and use them later on to compare those LLMs. And then we have to evaluate those models, right? For those, for this activity, we have evaluation tools like the one that we are going to see today, which is Amazon Bedrock evaluation tool, that can help us to, in a comprehensive and systematically way, assess the model's capabilities. And then we have the benchmarks. Benchmarks will provide a standard way of comparing and measuring metrics across different activities or different use cases and tasks. So we need these benchmarks because they are going to provide data sets, tasks, and a setup that is going to help us to compare those LLMs in a fair and systematic way. So now that we have seen the important characteristics that we need to consider to start filtering the LLMs that we want, and as well the metrics that we require, plus benchmarks and the evaluation tools, Marco is going to lead us and tell us how we can do the evaluation with Amazon Bedrock evaluation model. Thank you.
Yeah, so we've heard a lot about metrics, evaluation, tools, benchmarks, the characteristics, but now the question remains is how would we actually put that into practice, and how would we now start with selecting the LLM for our use case? So when you would start a use case, the first and most important thing to do is really to think about your priorities. So basically, you can select your model on different criteria, and there are a lot, but there are, let's say, 3 most important criteria that we always want to take a look at when we start our LLM use case in a business setting. And the first criterion is basically the quality of an LLM. And I think you all have a definition in mind what the quality is. So let's simplify it and say it's basically how good a certain model is able to perform a task. So how good a model can produce an output that is relevant for my use case. But isn't the answer then, let's always take the model with the best quality? And obviously, as I'm asking this question, it's no. Because models that produce the highest quality outputs, they are usually quite large, so they have a lot of layers, a lot of parameters, which means they, for example, have lower latency than other models. So they are not able to produce outputs very, very quickly, which is desirable for some use cases. So if you, for example, think about a chatbot and a user, or you want to use a new model which has a 5% better quality in your outputs, but it will increase latency for 40%, probably it's not a good user experience, right? And at the end of the day, we want to optimize the user experience and not just the quality of the outputs. Obviously, there is a criterion that is always important in our business applications, which is cost. So in your business, you want to use LLMs, you want to use Gen AI to tackle a certain business problem, to make your business more efficient, and there needs to be an economic benefit behind, right? So we need to consider, and it doesn't matter if we use a managed service like Amazon Bedrock, as Juan introduced, or you host your own LLMs, there's always a certain computational cost that we want to consider to create an economically valid use case. And these different criteria that I've mentioned are obviously you have to trade them off against each other. Because as I said, for example, if you have a large model which is very good in quality, you probably have higher latency, and maybe you also have higher costs. So it's always important to keep that in mind and set your priorities right at the beginning. But how do we now use these criteria to actually select our LLM? For this, we basically need a way of measuring analyze these criteria to compare different models against each other. And as you can imagine, cost is probably quite easy to measure, right? Because as I said, you have certain computational costs or certain input token, output token costs for your managed service that you consume your LLMs from, which you can use for doing a business case calculation and calculate the cost. For latency, it's also more or less easy to measure because you can provide an input to different models and then just measure the time that it takes to produce an output with the different models. So far, so good. Where it gets a bit more complicated and a bit more difficult is actually with measuring the quality of an LLM. And there are several reasons for this, but I chose the, let's say, for me, three most important reasons why quality measuring of an LLM is not very easy. The first reason is basically the multidimensionality of the quality of an LLM. What I mean with this is basically you have multiple dimensions that kind of play in the quality of an LLM. For example, you could measure how relevant the answers that an LLM gives are, so the answer relevancy. But you can also measure how factually correct the model is. Does it hallucinate, or does it just contain any fake information, any made-up information, which is obviously not good for the quality? Or you can even look at responsibility metrics and measure see if it outputs any toxic or harmful or offensive content, which is also not good for quality. So there are a lot of other dimensions, but I think you get the gist of it. Due to this multidimensionality, it is not very easy to directly say what the actual quality of an LLM means. The second reason why LLM quality evaluation is difficult is basically the same reason why LLMs are so great and seem like magic to us sometimes. Because sometimes you can think, okay, the LLM has a lot of wisdom and knows everything, and it produces great outputs on whatever I ask it. But actually, the LLM does not know anything. The LLM, or the underlying neural network architecture of an LLM, is basically just really, really, really good in understanding linguistic patterns and basically predicting the next tokens or the next word based on a certain sequence that was there before. Which means that is a probabilistic distribution function that we are having here. And by design, LLMs are non-deterministic, which is obviously difficult if you want to do an evaluation because you will lack some reliability. Because if you give the same inputs to the LLM 100 times, you'll probably end up with 100 different outputs. The third reason is basically that so far, and I mean, there's a lot of research going on in that field, there are no standardized metrics yet. So, as Juan said before, there are benchmarks, there are also metrics, but there's no real standard, so you cannot just start your use case and say, hey, I do this use case, so it's easy, I take this evaluation metric, and I evaluate it with this and that dimension. Probably this will evolve in the future, but so far this also makes LLM quality evaluation a bit more difficult. But now I'm telling you all the things that are difficult, so let's look at how we would actually try to create a structured process on how to really evaluate model quality and select our LLMs. So the, let's say, generic process of selecting an LLM is always more or less the same. A data engineer would start with many available LLMs. And with many, I mean hundreds, thousands, whatever is there in the internet, right, could be theoretically used. And you want to have a way of, first of all, shortlisting this And as Juan explained, there are certain characteristics of models, like input token size that the model can process, or if it's trained on a certain task that I want to use in my use case, or if the training data, whatever, is compliant to your company's rules and regulations. So there are a lot of key characteristics that I can already use to maybe shortlist it down to, let's say, 20 models. And from there, then do a second shortlisting iteration with maybe some manual testing and basically inspection, and also use some human judgment for checking whether the model actually is able to pursue the task that I want it to do. Currently in business, what we see a lot is basically that this is the only step that customers or that businesses are doing or projects are doing for selecting the LLM. So it's really based on a gut feeling of certain data engineers, certain prompt engineers, whatever, who are testing out things manually. And obviously, this is a good step because you can figure out if a model is suitable or not to a certain extent, but it should not be the only one. And the second step that we want to have, and this is the most important one, is basically we want to down select a certain number of LLMs. It doesn't need to be 3, these are just made up numbers, for having a structured evaluation procedure that we can carry out and that is reproducible and also accurately reflects how good the LLMs that we want to evaluate are. And obviously, last but not least, there's a third step, quite obvious. If you have all these evaluation results, you will basically select your model. And ideally, you also don't do that just once, but you have a setup that allows you for a repeated procedure, or for repeating this procedure when, for example, your input data changes or new models are released. So let's take a closer look at the first step, shortlisting. As I said, the model characteristics are important. We might already be able to down select. And coming back to the use case that Juan introduced earlier with the research paper summarization, we would probably start, or a prompt engineer would probably start to design some initial prompts for the summarization. And we would already take some input data, so some research papers, to test the things out manually and to try to get a feeling which LLM could be a potential candidate that we want to down select for the second step. So in the first step, we really want to trim the let's say, search space down to a certain number of LLMs that we take to the second step, where we will carry out the evaluation procedure. And how does the evaluation procedure now look like? So again, here on a generic level, it might always look the same, but obviously for your specific use case, it will vary. Generally, we would need some model inputs, so some input data that we can, and also some prompts that we can use for create model outputs for all the different models that we want to evaluate. And then as a third step, and this is probably the most important one, you need to have a certain judgment that needs to happen when on your outputs, basically, to create an evaluation. There are several approaches to this. You can, for example, do a human judging. So you actually have a team of people that are looking at your outputs and scoring them. And you'll have certain ratings that you want to apply, and you can create some metrics here. Or you have an automated approach that we will look into further, where you basically have certain algorithms that automatically calculate some scores for you, and then you can compare your models against each other. And as a last step as well, you want to compare the results, because at the end of the day, you will just end up with some evaluation results, but you need to draw conclusions from this yourself and then do your selection based on this. So again, we're looking in closer detail into the second step, and we'll stick to the example of the summarization from before. So what I would need to do here is basically I would need to set up the prompts, as I said before, as an input. So I have several prompts for summarization. And then what I would also need is the input data, so the research papers in our case. But more importantly, if you want to do an automated evaluation, you also need to have a certain, let's call it, ground truth data set, right? So a certain evaluation data set that you can use to compare your model outputs against afterwards. And this data set would basically contain, in our case, examples of summarizations that we classify as good summarizations of a certain research paper. Then we would basically run all these inputs through the different LLMs that we want to evaluate, that we shortlisted, and we would create the results. To then, in a third step, have a human or an automated evaluation. And in our case, To take this as an example, we would probably use a similarity metric and check basically, okay, here we have our ground truth summarization, and here we have the different model outputs, and we calculate how similar these outputs are to then end up with a certain score for the specific models that we evaluated, and have an idea on how they perform on our use case, on our specific data set that we want to use. But obviously this is a bit oversimplified, because how would you choose this metric? And also ideally, you would not just choose one metric, but you want to have kind of a bundle of metrics that actually reflect in the most or the best way how your LLMs perform. So what you want with your evaluation metrics are basically that they are A, reliable. So if you repeat the process, they should always output the same evaluation results. And B, you want them to be accurate. So you want them to reflect the actual quality and the actual behavior of the model and truly represent what the model is capable of doing. At the moment, there are two big groups, let's say, of metrics that you would usually choose from. One group is the statistical scores or metrics, the synonym here. And the other group are the model-based scores. And let's start with the statistical scores. They are really good because they are quite reliable, as they kind of depend on, or they are working with statistical methods to evaluate your outputs. So for example, they would count certain sequences of words in your ground truth data set and in your model outputs, and you can calculate certain metrics here then, which is quite reliable, because if you would do it over and over again and don't change any inputs or any parameters, it would stay the same. But obviously there is a downside to this, because if you're just using statistical methods here, we will have a shortcoming, which is that we won't take any semantics into account. So statistical scores are very bad in, for example, judging reasoning tasks. And this is why we have the second group, which are model-based scores. And these scores, they basically rely on natural language processing algorithms, like LLMs. So for example, you would have another LLM judging the outputs of the LLM that you're actually evaluating. And probably you already see the issue here, because I said we want to have an accurate metric, which this probably is, because it takes semantics into account. It is good in also reasoning tasks. But the problem is that it's not reliable, because as we said before, by nature, the LLMs are not deterministic. So if I use another LLM to evaluate my LLM, probably the outputs will differ every time I do this. And this is also why there is a large group in between where some frameworks and some researchers are trying to combine these two things and have statistical model-based scores, use them together to get a reliable and accurate measure. But the point I want to make here is basically, if you want to select your model, you would think about your metrics, which one to use. You would need to prepare your input data set. You would need to prepare your input prompts. If you want to do automated evaluation, you need to prepare your ground truth data set. And at the end of the day, you need any kind of workflow to actually produce all the outputs with the different models. So you already need to have a certain setup for doing inference on all these different models for just this evaluation task. And this is just a step before you actually start with developing a use case. This sounds like quite a lot of effort. And this is why I now want to introduce you to one feature of Amazon Model Bedrock, which tries to take away all this effort from you and basically does most of these things for you out of the box. The feature is called Model Evaluation in Amazon Bedrock. And it was exclusively built for evaluating, comparing, and selecting foundation models for your specific use case. So you can easily evaluate all the models from Amazon Bedrock. You can bring your own data sets so that it's tailored to your use case. You can do or choose either automatic evaluation, as I explained it, or even human evaluation and have an interface for this. I'll show that in a second. And you can also customize the criteria that you want to use. Plus, at the end of the day, it also offers you a user interface that you can read the results from. Because at the end of the day, as I said, we can produce a lot of evaluation results, but we need some kind of interface or a display of this data, because it's basically us, it's basically the humans, who then need to draw conclusions from that evaluation results. And how does the human evaluation in Amazon Bedrock work? So you would basically choose your models from the beginning that you want to evaluate. You choose your task type, for example, text generation or summarization. Then you can use recommended metrics or define your own. You upload your data set, and then you add people to a work team. That can be people from your organization or also AWS resources that you can get. And then after the inferencing of the different models, so after we created all the outputs with the different models that we shortlisted, we will have a human evaluation step where humans will actually look at the outputs and rate them based on the metrics that we defined before, which you can then use and view the results in the interface to assess the quality of the different models that you evaluated. The automatic evaluation is quite similar, actually. So the first 3-4 steps are the same. You choose your model, you choose your task type, you choose your metrics, and then you also upload your dataset. The step where it obviously differs is that after the inference, we will have the scoring, right? So the automated calculation of certain metrics and not a human evaluation step. And this is also already built in to Amazon Bedrock model evaluation. So you can choose different metrics. For example, you can choose accuracy or robustness, and the let's say logic or the code for calculating this is already built in and is already provided by Amazon Bedrock, so there's no need that you or your data science team needs to set that up from scratch. And then, same story, you would at the end of the day view the results in your user interface and draw your conclusions from it, choosing your best model. But obviously, just explaining this is not super nice, so let's take a look at this. I prepared a 1.5 minute demo that we now watch, and it will explain us how we would set up a model evaluation job in Amazon Bedrock and how we will basically, or how we are basically able to view the results and then compare the different models.
Amazon Bedrock's model evaluation tool makes it easier to identify the optimal model for your use case. We simply select our candidate model for evaluation. In this case, we'll evaluate Titan Text Express. Then we set our task type, General Text Generation Performance. Next, we'll specify our evaluation metrics. For this project, we're most interested in accuracy and robustness. For each metric, we can choose from the built-in datasets, or we can provide our own dataset stored in S3. Let's go with the built-in datasets. Next, we need to define the S3 bucket, where the evaluation results will be stored. Finally, we need to set the service role to allow Bedrock to upload data to the S3 bucket. Let's run the evaluation and check out our results. For accuracy, the model scored a 0.21, which means the model outputs scored low on accuracy. For robustness, the model was scored against 3 different datasets to compare how consistent it performed on slight changes to input prompts. The model scored very well in Wikitext 2, with a score of 0.968, and lower in the others. It's never been easier to choose the right model for your use case.
So as you could see, this is the way on how we can quite easily and quite quickly set up our model evaluation jobs in Amazon Bedrock Model Evaluation and then view the results in the exact same user interface, which will basically, as I said before, take away all the setup and preparation effort of your data, depending on how your setup is. So what you will end up with then, and now we're basically, we spoke about the step 2 and want to come to our last step, the step 3 that I introduced before, checking in on our priorities that we set before. You really now want to use your evaluation results to make a decision on which model is actually the best for your use case. And again, I'll take the example of the research paper summarization. So, as I said before, ideally when we started the use case that I said, we kind of thought about which criteria are the most important to us. So in this case, let's say the university, they are a bit, tight on budget, so cost is an important criteria, so it's prio 1. We have quality, which is like the second highest prio, and then we have the latency, which is not so important to us, so we accept that users might to wait a bit longer when they input something to get a response. So with what we have seen now, like the model evaluation feature in Amazon Bedrock, we have covered the quality part, right? So we have certain metrics that we calculated to judge which model is probably the best for our use case. And Amazon Bedrock also offers a user interface for you where you can provide the same inputs to different models and get information on how the latency was and how the costs, or what costs basically occurred for this request. So at the end of the day, you'll end up with your different metrics for each of these criterion. And you can, for example, say, okay, Foundation Model 2 did really well in cost. It's really expensive. It's really cheap, sorry. Maybe it's a cheaper model or a smaller model. It does okay in quality, so it's not the best, but it's also not the worst of my shortlisted models. And in terms of latency, it's also like somewhere in the middle, but as it's my prioritization, or it's my prior 3, I probably will not take that into account too much. So for our use case, we'll probably end up selecting Foundation Model 2. And I think the process here got clear. We really take all the different data and evaluation results that we can get from the evaluation feature of Bedrock and make our decision based on that in a structured way and with data that backs up our decision. So what I want you to take away now from the session and from what Juan and I presented is basically 3 things. So first of all, assess your situation thoroughly whenever you are starting your use case, as I said. So what is the exact use case you are tackling? And what resources do you also have? So maybe there are some, let's say, natural ways of selecting and shortlisting some LLMs because you have certain experiences and skills in your company, which is also very fair, right? So really assess your situation thoroughly and think about how you want to set up your use case and also your evaluation procedure before you're starting your use case. Second of all, and I mentioned that before, think about your metrics. Pick your most important metrics. Also, don't pick too many, right? Because you don't want to spend time and effort and resources on calculating whatever metrics that are not meaningful to you. This is probably not an easy step, but this is definitely very important to be efficient and selecting your LLM with a structured and valid approach. And third of all, and this is probably the most important thing that I would suggest to you, is that if you build this evaluation procedure, try to build it in a way that you can use it continuously. Because the next model that you will select for one use case will probably not the last model choice that you have to do for other use cases in your company. Or if there are new models that are released, as I said before, you also want to be able to quickly and easily get at least a feeling if that model makes sense to introduce to my use case, if it really has a benefit for my users and for my business. So keep evaluating your LLM choices and new models that you want to integrate. And I want to close this session now with basically 2 call to actions. So if you're interested in gaining some more in-demand skills also on Amazon Bedrock, on model evaluation, go to skillbuilder.aws. You can create a free account. You'll have plenty of materials and resources that you can use to learn and to start your generative AI journey. And second of all, please complete the session survey in your mobile app. So this is the AWS Events app that you probably or most likely have on your smartphones for today's event. I would be really happy if you give us some feedback on this.